Hello everyone, welcome to my channel. I am Balaji Chandrasekharan. Now I will be discussing few examples of using Java streams. This code snippet processes a stream of employees and collects the summary statistics including the count, sum, mean, average and max of their salaries for each department of employees. Here the collect operation is a terminal operation that collects the elements of the stream into a result. The grouping by collector in the collectors utility class groups the elements of the stream by a classifier function employee colon colon get department method reference which returns the department of each employee. For each department, it calculates the summary statistics on the salaries of the employees in that department using the summarizing double method of the collectors utility class. This results in a map where the keys are the departments of the employees and the values are the double summary statistics objects containing the summary statistics such as count, sum, mean, average, and max of salaries for each department. Overall, this code snippet produces a map where each department of employees is associated with the summary statistics of their salaries. These code snippets processes a stream of employees and collects the maximum salaried employee for each department. Here are given two approaches to achieve the final result. In the first approach, the grouping by collector groups the elements of the stream by a classifier function employee colon colon get department method reference which returns the department of each employee. For each department, it uses the reducing method of the collector's utility class to perform a reduction operation. The reduction operation calculates the maximum salaried employees within each department. The maxBy method in the binary operator class specifies the operation to find the maximum employee based on the salaries using a comparator. We need to use the minBy method if our need is to find the minimum salaried employee. In the second approach, the grouping by collector groups the elements of the stream by a classifier function employee colon colon get department which returns the department of each employee. For each department, it uses the maxBy method of the collector's utility class to find the maximum salaried employees within that department based on their salaries. The comparator is used to compare the employees based on their salaries. We need to use the mean by method if our need is to find the minimum salaried employee. Overall, this code snippet produces a map where each department of employee is associated with the maximum salaried employee within that department. The provided code snippet processes a stream of employees and retrieves the distinct departments of the employees, collecting them into a list. Let us break it down. The map intermediate operation maps each employee to its department using the get department method of the employee class. The distinct intermediate operation filters out duplicate departments, ensuring that only distinct departments are retained into the stream. The collect terminal operation collects the distinct departments into a list using the toList method of the collectors utility class. The provided code snippet processes a stream of employees, sorts them based on their joining year in ascending order, and then retrieves the first employee from the sorted stream. Let us break it down. The sorted intermediate operation sorts the employees in the stream based on their joining year. The comparingInt comparator is used to compare the employees based on their joining year. The findFirst terminal operation retrieves the first element of the sorted stream, which would be the employee with the least joining year after sorting. To find the nth matching senior employee by joining year, the sorted intermediate operation is used to sort the employees in the stream based on their joining year. The skip intermediate operation skips the first n-1 employees in the sorting stream. It discards the initial n-1 elements. Then the findFirst terminal operation retrieves the first element of the remaining stream, which would be the nth employee in the sorted stream. Overall, this code snippet finds one of first and nth matching employee with the least joining year among all the employees in the original stream. The partitioningBy method in the collectors utility class partitions the elements of the stream into two groups based on a given predicate. In my given example, the parallel stream creates a parallel stream of employees. The partitioningBy method partitions these employees into two groups based on whether their age is greater than 30. It takes a predicate which tests whether an employee's age is greater than 30. This method then partitions the stream elements based on the results of this predicate. The resulting map will have two partitions, one for employees older than 30, keyed by true, and the other for employees with 30 years old or younger, keyed by false. Finally, if we have a list of employees and we apply this operation, we shall get a map where the key true contains the list of employees older than 30 and the key false contains the list of employees with 30 years old or younger. Two strings are said to be anagram if we can form one string by arranging the characters of another string. For example, race and care. This code snippet is used to find whether the given strings are anagram by comparing the two input strings str1 and str2 by counting the occurrences of each character in both strings and checking if the counts are the same for each character. Here is a breakdown of the code. I created a map where the keys are the individual characters from string 1 by removing the white spaces first and converting into lowercase, and the values are the counts of occurrences of each character. Similarly, in the same way, I created a map for str2. The allMatch terminal operation returns true if all the entries in str1 map match certain conditions. Specifically, it checks if each character in str1 is also present in str2 and if the count of occurrence of each character in str1 matches the count in str2 using the given lambda expression. Overall, this code snippet determines if the counts of characters in str1 and str2 are the same. If all the characters have the same count in both strings, the method returns true, otherwise it returns false. The Fibonacci sequence is a set of steadily increasing numbers where each number is equal to the sum of the preceding two numbers. This code snippet generates the Fibonacci numbers and collects them as a comma separated string of string using the streams API. Each Fibonacci number is converted to a string using the string.value of method before being joined. Here is a breakdown. The stream iterate method creates an infinite number of Fibonacci number pairs starting with 0, 1. The lambda expression generates the next Fibonacci number pair by swapping and summing the previous pair elements. The limit method is an intermediate operation which limits the stream to produce only the count number of Fibonacci numbers. The first map method is an intermediate operation which extracts the first element of the Fibonacci number from each pair. The next map method is again an intermediate operation which maps each Fibonacci number into its string representation using the value of method of string class. The collect operation is a terminal operation which collects the string representation of the Fibonacci numbers into a single stream using the joining method of the collectors utility class which joins them with the commas and spaces. Overall, this code snippet efficiently generates Fibonacci numbers and collects them as a comma separated string of strings. With this, we came to the end of the session. Thanks for watching my video.